this is Tanya Rowling. I'm back with another video. Do watch my other videos as well. I would be teaching CBSE Class 10 Maths NCERT syllabus and my sister Tina Lofus would be teaching CBSE Class 8 Maths NCERT syllabus. Alright, now let's get into the video. Today we are going to be learning exercise 1.3 second question. Prove that 3 plus 2 root 5 is irrational. So this is the question. So in this question we have got 3 plus 2 root 5. So this is somewhat complicated because we have addition and we have root 5 and it is in the multiplication form. So it is somewhat difficult. But in the previous sum, that is the first question, we solved root 5 is irrational, which was easy. So here also when you understand this, it is really easy. So here you guys can see 3 plus 2 root 5 is irrational. We should prove that. For proving it, first of all we should prove root 5 is irrational. So what you are going to do is, in the first question, the question is root 5 is irrational. For that, whatever steps, whatever things we wrote, no, you should write that at first. You should write, let us assume root 5 is rational number, and you should write p by q, and after that whatever things I solved in the first sum, no, you should write it as it is. After that you should prove that 3 plus 2 root 5 is irrational. Okay, I hope you understood what I am trying to say. First of all, you should prove that root 5 is irrational. That one I had already uploaded in the previous video. So please write those steps. After that you should write 3 plus 2 root 5 is irrational. Now we are going to be doing that. Okay, if you want, let me write that too. So I wrote, write root 5 is irrational at first. Okay, so you should write root 5 is irrational and you should write those steps. This is really important. You should write this root 5. And now we are going to be writing, to prove 3 plus 2 root 5 is irrational, we assume 3 plus 2 root 5 is rational number. Now let's write that. So now I wrote, to prove 3 plus 2 root 5 is irrational, we assume 3 plus 2 root 5 is rational number. Okay, so now we are going to be writing rational number form. So rational number is in the form p by q, where q is not equal to 0. Now let's write that. Now let's write 3 plus 2 root 5 is equal to p by q, where q is not equal to 0, where p and q are co-primes. Okay, we wrote it. So now we wrote where p and q are co-primes. So as you guys know what are co-primes, I had already uploaded what are co-primes, but still now let me just tell you what are co-primes, okay, in short. So first of all, co-primes means, so for HCF, so as you guys know, in exercise 1.2 we found the HCF of a particular number and LCM of a particular number. So suppose if we don't have a HCF for two numbers, then what we do is we take one as its HCF. So in that two numbers, if we don't get any common numbers, what we do is we take one as its common number. So that one is its co-prime. Okay, so in case if we don't have a HCF, we take one as its HCF as a common number. Okay, so that is known as co-primes. Now let's write the form, that is 3 plus 2 root 5 is equal to p by q. So this is the form. Now we shall write 2 root 5 is equal to p by q. So you guys might think, what about 3? So here the 3 is in the addition form. So when it comes to this side, when it crosses this bridge, that is the is equal to sign, then when it comes this side, then it becomes minus 3. Okay, so we took this 3 this side. Okay, then it became minus 3. Okay, because here it is in the addition form, that means plus 3. Okay, so here it is in the fraction form, that means we shall write divided by 1. Okay, so we don't have any other values, so we wrote 1. Now we are going to be taking LCM of q and 1. Okay, of course you know LCM of q and 1 is of course q. Okay, so now we shall write, so now I am writing p by q as it is. So this one I am doing for LCM, we got LCM q, am I right? So already we have q, that means 1 p is p and 1 q is q. Okay, so now it is p by q. So you guys might ask, why am I doing like this? Because after taking LCM we are supposed to do like this. Okay, this is very important, you guys should remember this. And that too, we had already studied this in 7th 8th standard. I guess you guys remember those. So now it is p by q, and next let's take the next term, that is 3 by 1. So it is minus 3 by 1. So here we should get the denominator as q. So we shall multiply it with q. Okay, so q, so is equal to minus 3 into q is minus 3q, and 1 into q is q. Okay, so we got minus 3q divided by q. Now let's write this form and let's write this form separately. So now let's write p by q, and we shall write this one, that is minus 3q by q. So we got this form. Okay, so here denominator, no, let me show that. So here the denominator, it is q, so we shall write p minus 3q divided by q. So both are q, right? So instead of writing 2q, we can write 1q as common. Okay, q is common. So I wrote p minus 3q divided by q. Okay, so finally we got this one, that is p minus 3q divided by q. So now what we are going to do is, we are going to write 2 root 5 is equal to, so we solved this one and finally we got the answer p minus 3q divided by q. So we are going to write this. Okay, first we are going to be writing 2 root 5 is equal to, then we are going to be writing p minus 3q divided by q. So now let's write 2 root 5 is equal to, so p minus 3q divided by q. Okay, so after this we shall write root 5 is equal to p minus 3q divided by, so here it is in the multiplication form, so it is 2 into root 5, am I right? So what we are going to do is, if it is in the multiplication form, when it crosses this bridge, that is equal to sign, when it crosses this, then it changed into division, so it is 2 and we have q, so I shall write q. So now it is p minus 3q divided by 2q. So finally we got the answer. Okay, this is somewhat tricky because we should find the root 5, and first we found the root 5 and then we are just solving it. Okay, we know that root 5 is irrational and p minus 3q divided by 2q is rational. We get a contradiction, therefore 3 plus 2 root 5 is irrational. Okay, first we proved root 5 is irrational and we solved it, and next p minus 3q divided by 2q, it is rational. So now it is rational, then what we do is we take contradiction. Contradiction means conclusion. After contradiction we got it is irrational. Okay, let me show that. So here you guys can see in the question they mentioned irrational, but in the answer we assumed it as rational number. That's because we can't solve the problem if we take it as a irrational, but we can solve this problem by taking it as a rational number, because rational number is only in the form p by q, where q is not equal to 0. So in mathematics, rational number it is always in the form p by q, where q is not equal to 0. So we prove that rational number, it is in the form p by q where q is not equal to 0. So that is the concept for rational number, but for irrational number that is not a concept. Okay, so if we take rational number, then only we can solve this question. If we don't take rational number, then we can't solve this question. It is really very difficult to solve this question. So that's why first we took rational number. Actually we are supposed to take irrational number according to the question, but we took rational number. That's because rational number is in the form p by q where q is not equal to 0. So in the end of the video, I mean in the end of the sum, we just wrote that it is a contradiction. That means first, instead of taking irrational, we took rational. So in the end of the sum, we told them that we didn't take the true statement, that is irrational. Instead we took rational number. Rational number, it is a false statement. Okay, so we are supposed to take irrational number, but we didn't take irrational, we took rational. Just because of that we wrote that it is a contradiction. So after contradiction we just proved that it is irrational. Okay, let me show that. See, after contradiction we wrote it is irrational. Okay, so after proving rational and after doing all those things, we just wrote that it is a contradiction. So it is a rational number, it is a false statement. We are supposed to take irrational number, but we took rational number. So that's why we wrote contradiction and then we wrote it is irrational. Okay, so this is the main process and main concept in this question. Okay, you should understand. If you want, you can just surf in the internet about contradiction, because contradiction, no, we have various meanings for that. Okay, so for in maths the meaning is, if it is contradiction means it is instead of taking irrational. For example, instead of taking irrational we took rational. So that is a false one, that is a wrong one. If we take some other number instead of a particular number, we get an answer. Am I right? That might be wrong or that might be correct. But in this question, just because we took rational number, we just solve this question. If we don't have rational number, it is really hard to solve this question or examples of these questions. Okay, so that's why after contradiction we just prove that it is irrational. Pretty sure that you guys enjoyed this video. Please like this video, share it to your friends and subscribe to our YouTube channel. If you have any doubt, you can comment me in the comment section. See you in the next video. Bye.